Classmates, listen up. This is the map to Sen's place.
Why? What's that for?
We will assemble at the vacant lot beside Sen's place for tomorrow's trip to the orphanage.
Why can't we assemble here in school instead? I don't know how to get to Sen's.
Well, tomorrow's a holiday and school will be closed. Sen's place is the closest to school.
Okay. Hey, look! Miss Michelle is coming.
Alright then, assembly is at 7 a.m. and we leave at 8 a.m. Don't forget to bring your gifts and prizes for the games. I will distribute copies of the map before dismissal.
Wait! Leave it. I can use it for today's lesson. You have a nice map. Who drew this?
Those Ines.
You're good. Can you identify some parallel streets on this map?
Molave and Nara streets are parallel.
Sampaloc Street is also parallel to Rodriguez Avenue.
That's good. Now, how is Sampaloc Street related to Molave and Nara streets?
Well, Sampaloc Street is not parallel to any of these streets.
Why do you say that?
Sampaloc Street intersects each of these streets, so it is not parallel to them.
That's right. If these streets were represented by lines, then the first two streets can be represented by parallel lines, and Sampaloc Street will be denoted by another line that intersects the parallel lines, like this. Can you recall the name we give to such a line?
Ma'am, I think it's a transversal.
Yes, it is a transversal. For today, we will discuss transversals that cut a set of parallel lines and the angles formed by these intersections. What objects in real life illustrate parallel lines cut by a transversal?
I think the rungs of the ladder can be the parallel lines, and the vertical supports will be the transversals.
Railroad tracks also represent parallel lines cut by transversals.
The lines painted on the street to mark a pedestrian lane can be our parallel lines.
Yes, but what would be your transversal there?
Why, the path made by a pedestrian crossing the street, of course.
Very good. I see that you understand what a transversal is. We are going to study angles formed by a transversal that cuts a set of parallel lines. We have here two lines and a transversal. How many angles do you see?
I see 8. 2 above the first line, 4 between the two lines, and 2 more below the second line.
Very good. Let's label the angles so we can study them in greater detail.
I'll do it.
Angles C, D, E, and F are called interior angles, while angles A, B, G, and H are called exterior angles. Can anyone tell the difference between interior and exterior angles?
Well, I see that the interior angles lie between the two lines, while the exterior angles lie above and below the two lines.
Yes, good observation. All of the angles are formed by the two lines with the transversal, and those that lie in the region between the two lines are the interior angles. We will be studying some special pairs of these angles. Angles C and F form a pair called alternate interior angles, and so do angles E and D. What common property does these pairs of angles have?
Well, they are all interior angles.
What if I say that angles C and E are not alternate interior angles?
Angles C and E lie on the same side of the transversal, while the angles that form alternate interior angles lie on different sides of the transversal.
That's true, but C and D also lie on different sides of the transversal, but they are not alternate interior angles. What other characteristics describes these angles?
One angle is at the upper part and the other is on the lower part of the region between the two lines.
That's correct. Let us summarize the properties of alternate interior angles.
Miss Michelle, do you also have alternate exterior angles?
That's a good question. Yes, in fact, we do, and their properties are similar to alternate exterior angles. Can anyone describe these properties?
They are like alternate interior angles. They must be on opposite sides of the transversal.
They must be both exterior angles.
Yes, that's right. Can anyone give a formal definition of alternate exterior angles?
From what Doms and Dancel said, two exterior angles are alternate exterior angles if they lie on opposite sides of a transversal.
Now, let's study another kind of angle pairs. Angles A and E, C and G, B and F, and D and H are examples of this new kind of pair. These are the only such pairs in the figure. Who can tell what properties these pairs have?
Each pair consists of one interior and one exterior angle.
Good. What else?
The angles in each pair are non-adjacent.
That's right. What else?
Is there something else?
Miss Michelle said that those four pairs are the only angle pairs of this type. But the pair of B and E satisfy these two properties too. I think that the difference is that these two angles lie on opposite sides of the transversal, while the angles in each of the four pairs are on the same side of the transversal.
Very good, Sen. These angle pairs are called corresponding angles. Doms, can you tell me what corresponding angles are?
From what we have discussed, these would be two angles, one exterior and one interior, which are non-adjacent and are located on the same side of the transversal.
We have two more special pairs of angles to define. The first one is illustrated by angles C and E, as well as by angles D and F. These are called consecutive interior angles. Can anyone describe the properties of these pairs?
The common property of these pairs of angles is that they are interior angles that are located on the same side of a transversal.
Very good, Maurice.
Miss Michelle, do we also have consecutive exterior angles?
Yes, that's so. In fact, this is the last special pair we will define. Can you identify a pair of consecutive exterior angles in our figure?
How about angles A and B?
No, I'm sorry. Yes, they are both exterior angles. But think about what Marie said about consecutive interior angles. Consecutive exterior angles have a similar relationship.
I think I know now. The angles have to be on the same side of the transversal. Then A and G must be consecutive exterior angles.
Yes, you're right. What other angles form this kind of pair?
I think B and H are consecutive exterior angles.
Yes, very good. Now let's see if you can properly identify these angle pairs. Each of the lines L, M, and N is a transversal of the other two lines. I will identify pairs of angles and you will tell what kind of pair they form. Angle 6 and angle 3.
Consecutive interior.
Angle 11 and angle 1.
Alternate exterior.
Angle 4 and angle 10.
Alternate interior.
Angle 8 and angle 2.
Corresponding angles.
Angle 5 and angle 9.
Consecutive exterior.
Now that we have identified the different pairs of angles formed when lines are cut by transversals, we will study their properties when the given lines are parallel. Take a look at this figure.
What is that, Miss Michelle?
This is an angle pair device that forms a movable parallelogram. It will help us study the angle pairs. The strips represent two pairs of parallel lines. Can you tell which line will be transversal?
But Miss Michelle, we now have 4 lines, but we only had 3 lines earlier.
Can you recall how we define a transversal?
I can. It's a line that intersects a set of lines at distinct points.
All right then, which of the lines in our figure satisfies this definition?
Let me see. Why I think each of the 4 lines is a transversal?
And why do you say that?
Each line intersects a pair of parallel lines.
Class, do you agree with Maurice?
Yes!
I need 3 volunteers to identify 3 pairs of corresponding angles formed by our device and to find their measures. What can we say about the measures of corresponding angles formed by parallel lines?
It looks like they have the same measures.
Yes, that's right. This illustrates the so-called corresponding angles postulate.